All right, we are looking at section 2.1. Calculus is all about three different concepts. The first concept is limits, and we talked about limits. We've done that. The second part of calculus is differentiation. That's what we're going to be starting now. Differentiation, this has to do with finding derivatives, and when we find derivatives, we're actually finding the instantaneous rate of change. I'm good for today, Colin. So the other thing is we do integration. If we're trying to find the average rate of change, that means the same thing as the slope. So we want to have the 2 points close together, but basically when we're doing average rate of change, the 2 points just are going to be where they are. When we're finding instantaneous rate of change, we want to find the slope at a single point, so therefore we're going to have to get the 2 points very close together. So on average rate of change, this is really just our slope formula. We plug in the second value into our function, minus the first value goes into our function, and then it's all over b minus a. This is the way you're used to seeing average rate of change or slope, but we're also going to be using this way also. Again, instantaneous rate of change is where we're trying to go. This will tell us the slope at one specific point. So this formula means that we're going to still be using slope, but we need for this point B to be very, very close to the point A. The other way we can think of it is we've got the y value, and we're going to go over just a little bit, and we're going to call that little bit delta x. Sometimes we also see it called h. And we're going to let that delta x get very close to 0, so that basically these 2 points are just 1 point. So these two formulas look very different, but the concept is the same. We're trying to find the slope at 1 point. Let's look at some examples though. Before we do instantaneous rate of change, let's look at average rate of change. Highlight the line with the slope that represents the average rate of change between A and B in blue. I'm going to use purple since that's what I've got. Here's point A, here's point B. The average rate of change is going to be this line right there. Highlight the line with the slope that represents the instantaneous rate of change at x equals b in red. I'm going to use orange, if that's what I've got. Right here is point B. If I want the instantaneous rate of change, it's actually going to be the line that's tangent to B. That's what we're going to be doing starting tomorrow. But for now, we're just going to be looking at these average rates of change. Looking down here, find the average rate of change between A equals -2 and B equals 1. So we're looking up here at this example. Right here, this point A is going to be at what's the coordinate for point A? Can you guys tell? Actually, yeah, I guess they are talking. I think they're talking about this picture now. Okay, we're down here now. Find the average rate of change between A equals -2 and B equals 1. Yeah. So they're talking about these 2 points that we're going to find the average rate of change between. Well, this is just slope. We're just trying to find what's the slope between those 2 points. So I just write those 2 points. -2, 1. And 1, 4. So to find the slope there, it's just going to be 4 minus 1 over 1 minus -2. That's going to be 3 over 3, and so that slope is 1. Find the average rate of change between -0.25 for A and +0.25 for B. So here's -0.25, here's +0.25. We want to find the average rate of change there. So again, we're just going to find the slope between those 2 points. So I'm going to do this y, and I'm going to abbreviate average rate of change as AROC. So I'm going to do this y of 1.563 minus this y of 0.563 all over this x of 0.25 minus this x of negative 0.25. So in the numerator, we've got 1.563 minus 0.563, that's going to be 1. In the denominator, we have 0.25 minus negative 0.25, that's going to be 0.5. What is 1 divided by a half going to be? 2. So this is 2. Which average rate of change is a better approximation for the instantaneous rate of change at x equals 0? Here's x equals 0 right here. Which of those 2 points are closer together, the one in orange or the one in purple? I'm trying to find really the slope right here at 0. Is this a very good approximation for the slope of 0? No. But this one would be a pretty good approximation. So this slope is closer to 2 than it is to 1. So we would say then that the purple is going to be the better representation or approximation. So now this is a completely different problem. It says find the average rate of change for f of x equals x squared minus x over this interval. These are x values. So this is saying from when x equals 2 to x equals 3. You can also think of this as being the a value and this is the b value. So we need to find those values. If I plug in 2 into f of x, what are we going to get? 2. What about if we plug 3 in for x in this function? What are we going to get? 6. So this would be a, this would be f of a, this would be b, and this would be f of b. Average rate of change is the same thing as slope, but you need to get used to this new notation. So our average rate of change is going to be f of b minus f of a over b minus a. F of b is 6 minus f of a is 2, b is 3, a is 2, we're going to get 4 over 1, so 4 is going to be the average rate of change. And we're able to do that without even having a graph. We're just plugging into the function. Alright, let's go to the next page. So we need to get used to not having a picture, because that's our whole goal, is to be able to find average rate of change without having a diagram. What would I do here then if I have this function and I want to find the average rate of change from 1 to 4? What would we have to do? Jasmine? Okay, so what do we get if we plug in 1? And if we plug in 4, 20. And so this is really a, f of a, b, f of b, just like the one we just did. So our average rate of change is going to be 20 minus 5 over 4 minus 1, 15 over 3, so it's 5. Now, another way we look at average rate of change is we may have like a word problem situation. So on day 10, we have 200 bacteria in a petri dish. On day 15, there are 522 bacteria. Well, they're really just giving us an ordered pair. Day 10 is 200. Day 15 is 522. To find the average rate of change, we do the same thing we've been doing. We have to do 522 minus 200 over 15 minus 10. So that's going to be 322 divided by 5. Don't grab a calculator, just do it this way. 32 divided by 5 would be 6 with 2 left over. 22 divided by 5 would be 4 with 2 left over. So it's 64 2/5, which is 64.4, and now I need to use the correct units. It's going to be bacteria, the change in bacteria, divided by the change in the day. So this would be 64.4 bacteria per day. When you do your worksheet tonight, it's going to ask you to use the correct units. So you need to make sure you do that. Okay, number 5. We have f of x equals 2 plus cosine x. We're trying to find the average rate of change between 0 and pi. Do you guys know what this function looks like? Do you remember the key points for cosine from 0 to 2 pi? Good. Those are our normal 5 key points between 0 and 2 pi. What if I have plus 2 though? What's that going to do to the values? Shift them up 2. So now this is 3, this is 2, this is going to be 1. I'm not going to finish because I'm only looking between 0 and pi. If I'm trying to find the average rate of change between 0 and pi, I can now do it just by having this set up. I can go ahead and do my y. Well, let's go ahead and write the points down. We have the point 0, 3, and we have the point pi 1. So to find that average rate of change, it's going to be 1 minus 3 over pi minus 0. 1 minus 3 is negative 2. Pi minus 0 is pi. And so negative 2 over pi is going to be that average rate of change. If you kind of look at it, we can check. This goes 3, 2, 1. So it's like this. I'm trying to find this average rate of change. I can see it's a negative slope, so that makes sense. Number 6, we did this in the warm-up. Find the equation of the line through these points. Everybody knows how to do that, right? First, find the slope. Then we use y minus y sub 1 equals m times x minus x sub 1. We're not going to take the time to do that one. All right, let's do this last one here. Find the average rate of change over the interval from 0 to 12. Any ideas of what we should do when we're given a graph? Jasmine? Okay, so when x is 0, what's y going to be? And when x is 12, what's y going to be? And now we can find the average rate of change. 4 minus 0 over 12 minus 0, 4/12 is 1/3. We don't have any units, so we just write 1/3. Okay, any questions over that? All right, so you guys are going to do worksheet 2.11, and it's on Canvas for you.